Hi guys, let's continue with our engineering mathematics 1 tutorials. Okay, this is part 3. We are at number 4b. This one. Okay, let's begin. We have sine 2x minus sine 4x equals 0. Okay, let's begin. Here what we need is to make sure we have the same angle variable. If we have x, we must have x. We use 2x, they must all have 2x. They must have a common or the same angle variable. Okay, let's begin. Okay, you will have sine 2x minus sine. Okay, you can open bracket here and say 2 times 2x close bracket equals 0. Okay, then here you will have, here you can see that the identity that you will have to use here. We know that we have an identity that states sine 2 theta equal to sine theta cos theta. Okay, therefore if you have sine 2x, what will you have? Let's continue, we'll see just now. Okay, then here, okay, I can just erase this one here. Yes, we'll be working with it. You will have sine 2x minus 2 sine 2x cos 2x equal 0. Okay, then from this equation we can see that our common factor is 2 sine 2x. We can take it out and open bracket 1 minus 2 cos 2x close bracket equal 0. Okay, then from here you will say sine 2x equals 0, or 1 minus 2 cos 2x equal 0. Okay, then okay, let's start with this part here. Here we can first determine our reference angle here. Okay, it's better to work with general solutions. Angle ref equal sine arcsine. Okay, arcsine 0. Therefore here you will get 0 degrees. Okay, then from here you can say 2x equal 0 degrees plus 360 degrees multiplied by k. General solution. The reason we use 360 because we know the period for a sine function is 360. Okay, then from here x equal 0 degrees plus 180 degrees multiplied by k. Okay, so let's go this side. This side you will have 1 minus 2 cos 2x equal 0. Okay, then you will have 2 cos 2x equal 1 cos 2x equal 0.5. You divide both sides by 2. Then here you also determine reference angle, okay, which equal arc cos 0.5. okay, what our arc cos 0.5, I think 60 degrees here. I think it's 60 degrees. Okay, yeah, arc cos 0.5 60 degrees. Okay, we have 60 degrees here as our reference angle. Okay, the reason I'm working with degrees here, I can see there's no sign of this equation being in radians. I don't see any pi. So in most cases when you see pi in your equation, you know that equation is in radians, but this time around I don't have any information showing that. Okay, then let's continue. Then you will use your Cartesian plane. Okay, we know that with the let me see where I can draw it. Okay, let me draw it here. You know that with a Cartesian plane, you know the first quadrant all they are positive. Okay, second quadrant, it is sine, which is positive, and we have 180 degrees minus. Okay, let me just say sine, not necessarily full term. This side we have tan, and it is 180 degrees plus theta. This side we have cos, it is minus theta here, that it is only cos that will be positive, this quadrant, 360 degrees minus theta. Okay, all positive, only sine, only tan, only cos. Now let's determine the general solution here. Then you will consider the first quadrant where cos is also positive. Therefore 2x equal 60 degrees plus 360 degrees multiplied by k. Okay, therefore from here you'll have x equal 30 degrees plus 180 degrees multiplied by k. Okay, or let's go for another quadrant where cos is positive, third quadrant. You'll have 2x equal minus 60 degrees plus 360 degrees multiplied by k. Okay, then here you'll have x equal minus 30 degrees plus 180 degrees multiplied by k. Okay, then let's continue again to the same quadrant. You will still have 360, right? Then you'll have 2x equal 360 degrees minus 60 degrees plus 360 degrees multiplied by k. This multiplication, we just consider every cycle. The first cycle, when it ends, when it creates, when it makes this thing, then it has to start again, like a sine waveform, a cosine waveform, not a sine. Okay, then here you'll have 2x equal 300 degrees plus 360 degrees multiplied by k. Therefore x here equal 150 degrees plus 180 degrees multiplied by k. Okay, then from all this we can say that the values of x are let me just do this just to highlight all of them inside. The same, we have 0 degrees, or let me start with the negative. We have minus, let me do this. Let's double check the minus before we continue. If you can go back up there, right? We'll say sine 2 multiplied by minus 30, okay, minus sine 4 multiplied by minus 30. We don't get, okay, let me do this. 4 multiplied by minus 30, we get 0. Okay, therefore it's usually recommended to double check your solutions with the original equation. Double check your solutions with the original equations. Then here you'll have minus 30, you'll have 0 degrees, you'll have 30 degrees, you'll have what follows? You'll have 30, okay, you'll have 150. Okay, you can always double check these solutions. Okay, yeah, I think we are done with this question. Now let's continue to number 5. Remember, this is part 3. We already solved other questions in other parts of the videos uploaded. Okay, number 5, we have hyperbolic function here. If sine hx equals 5/12, use identities to determine the following. Okay, let's begin. Okay, number 5, we have sine hx equal 5/12. Okay, number A. number A, they say we must determine cos h squared x. Okay, so but instead of just writing it down, I think we should first come up with the identity that we're gonna use here. We know that cos h squared x minus sine h squared x equal 1 when we use trigonometric, hyperbolic functions, hyperbolic identities. Cos h squared x minus sine h squared x equal 1. Cos h squared x plus sine h squared x equal cos h 2x. Hyperbolic functions, hyperbolic identities. Okay, then here let's see what we have here. Okay, here you have cos h squared x equal 1 plus sine h squared. Okay, for here you'll have 1 plus, you can substitute 5 over 12 and square it, because the initial one is given value is not squared. Therefore you can just punch everything here on your calculator to be quick on during your test. Okay, therefore you'll have 169 over 144. Okay, then let's go to number B. Number B is this one. Okay, they want us to find cos h 2x. Cos h 2x equal, just identity I just wrote down earlier on. We said cos h squared x plus sine h squared x equal cos h 2x. Okay, hyperbolic functions, hyperbolic identities. For this one equal cos h 2x plus sine h exponent 2x. Okay, therefore this equal 169 over 144 plus 5 over 12. Okay, squared. Therefore you can punch this one on your calculator. Therefore your answer will be 97 over 72. Okay, then let's go to number C. Number C, we have sine h 2x. Okay, therefore this identity is very common with the trigonometric identity. Sine h 2x equal 2 sine hx cos hx. Okay, then you can come back here and say equal 2 sine hx cos hx. Therefore you have 5 over 12 multiplied by, okay, you can just apply the square root to that initial answer that you had. The square root of 169 over 144. 169 over 144. Okay, then you can punch all this on your calculator. 5 over 12 multiplied by 1 square root of 169 over 144, which is 65 over 72. Okay, that's how you solve this one. Okay, let's continue to number 6. Number 6 is about limits. Okay, limits. Let's read the question. Determine the limit of each of the following functions. Okay, we have number A here. Let's go solve number A. Okay, number 5A. Okay, let me have a picture of it so I can write it down without double checking. We have lim x approaches 2 x exponent 3x minus 8 exponent x over x exponent 2x minus 4 exponent x. Okay, let's try to simplify this one. We will have lim x approaches 2. This lim you must always write it down until we substitute 2. We'll have x, okay, x exponent x, okay, open bracket, close bracket, exponent 3 here. Okay, then minus, that's how you must always approach it, minus 2 exponent x. We still have x there at the exponent, right? Close bracket, exponent 3, because we know that 2 exponent 3 equal 8. Okay, that's how you can simplify the third one. Okay, all over, open brackets, x exponent x, close bracket, exponent 2 minus, open brackets, 2 exponent x, close bracket, exponent 2. Okay, then from here you can use the let method. This technique is very helpful to simplify situations. The let method. Okay, you can say let, okay, you can just say let m equal x exponent x, okay, and n equal 2 exponent x. Okay, then now we're gonna continue from here. You will say choose the one. You will say lim x approaches 2, okay, lim x approaches 2 and m, okay, let's remove the brackets now and just put those variables. M exponent 3 minus n exponent 3 over m exponent 2 minus n exponent 2. Now we are substituting from this information here. Okay, you can see where we are substituting. We are using the let method. Okay, let's continue. From here you just continue to say lim x approaches 2. Now we're gonna use, we have a difference of 2 cubes. When you factorize difference of 2 cubes, the formula is there, is standard. You will have m minus n, m squared plus mn plus n squared, okay, over, when you factorize difference of 2 squares, you'll have m minus n, close bracket, open bracket, m plus n. Okay, it's open bracket m minus n, close bracket, open bracket, m plus n. That's how we factorize difference of 2 squares. Okay, therefore you'll have lim x approaches 2. Okay, this one is gonna cancel out this one. Okay, then you'll have m squared plus mn plus n squared over m plus n. Now we can bring back those exponents we have here. Just to remind yourself, is x exponent x and 2 exponent x. X exponent x, right? Therefore we'll have exponent 2x plus x exponent x. Okay, you must always double check. Multiplied by 2 exponent x plus 2 exponent 2x, because we have exponent 2 here. Okay, over x exponent x plus 2 exponent x. Now we can substitute. I think we removed the problem there. We can now substitute and say our answer here, we will have 2 exponent 2 multiplied by 2 plus 2 exponent 2 multiplied by 2 exponent 2 plus 2 exponent 2 multiplied by 2, okay, over 2 exponent 2 plus 2 exponent 2. Now here you know you have this one should be 2 exponent 4, I think it's 16 plus 16, 2 exponent 2 multiplied by 2 exponent 2 plus 16, okay, over 4 plus 4. Okay, then from here you'll have 16 times 3 over 8. So your answer is 6. Okay, that's the solution to this limit question. Now let's do the second one, B. The second one, B. Okay, this one we're working with the radians there. Okay, let's solve that one. You have number, is it number 5? I think we are solving number question 6, not 5. My bad. Let's continue. Question 6, number B. Okay, we have lim x approaches pi over 4, 1 minus tan x over sine x minus cos x. Okay, it's 5 marks. If you try to substitute pi over 4 here, it's gonna be undefined. Okay, therefore you have to simplify this thing. Now let's begin. You have lim x approaches pi over 4, 1 minus sine x over cos x. Okay, we know the identity, right? I mean the trigonometry function like this: tan theta equal sine theta over cos theta. We use that one. Okay, over sine x minus cos x. You just go with the flow and try to simplify it. Okay, lim x approaches pi over 4. Okay, here we have, and let's take this one here and multiply. You know how we work with fractions, right? Let me just do it aside just to show you. If you have a 1 minus sine x over cos x, you know you're gonna take this one and multiply this one here. We have cos x minus sine x over cos x. You see, that's how you're gonna do it. Let's continue. That's how you do fractions. Therefore you'll have cos x minus sine x over cos x. Okay, therefore you can say divided, you can open bracket here, open bracket, sine x minus cos x. That's the case here, right? That's what you divide with here, and this is simply over 1. Okay, simply over 1. Therefore you'll have lim x approaches pi over 4, okay, cos x minus sine x over cos x. Then you say multiply, then this one it switches position with the numerator, then here you'll have sine x minus cos x. Okay, but here you must look at these two terms in this on this denominator expression and this numerator expression. We need to swap their positions. Let's just do the next step just to swap their positions. X approaches pi over 4. You will have okay, let's say you'll have minus open bracket sine x minus cos x. Okay, you know, if you bring this minus into the brackets, you will have minus x as it is here. Okay, let me just do it aside just to show you. You will have something like this, minus sine x open bracket sine x minus cos x. If you were to further this, you will have minus sine x plus cos x, which will be cos x minus sine x will be the same as this one, right? We just rearrange the terms, okay, over cos x multiplied by 1 over sine x minus cos x. Therefore this one is going to cancel this one, right? And let's continue. Therefore here you have lim x approaches pi over 4 minus 1 over cos x. Now you can substitute your minus 1 over cos pi over 4. Okay, minus 1 over cos pi. Do not forget to convert your calculator to radians. So your answer here is minus root 2. Yeah, minus root 2. I think that's it here. Okay, then first principle, I think this one will take longer. I think I will create videos aside whereby I do derivatives. Like I can probably have 3 questions whereby we do a derivative from first principle. So I will do them in a separate video. I can probably have 3 questions there or 4 just doing derivatives of functions from first principles. Okay, so I think we can end the video here. Thank you.